Here we have the rubber being complete. Now this will help with grip, and these rubber bands will help with grip and grip. And also better steering because it has more traction. Now, the problem is, or I fear from a truck, is these are plastic rails. They're strong enough, I know. Hold on. Putting the pressure on one point is not a good practice because you can just use all the surface area to distribute the weight evenly on every single point instead of just one single point. One single point can be damaging and or more dangerous than having it all distributed, of course, as you know. So we could put 2 rubber bands on each wheel, or even 3. Now, I'm actually going to do a test without gluing these wheels. Also, I'm not sure about how they work. How good they are. I forgot to do a test without the wheel, but I've already driven the car without the wheel rubber before, so this won't be troubling. But this time I have to drive this in my hands because I don't have the Arduino connected to it no more. Instead, I used the Arduino for this controller. As you can see, this one. Now, this controller is a good one I made. Here's a controller circuit. So we have basically it's like an Xbox controller. So I'm going to show you one. Now, as I have said before, this is, as you can see. So I basically tried to copy an Xbox controller's layout. As we could see, is these buttons are a little higher than the joystick in here. Button is higher than the joystick, as you can see. So we have the, of course, A, B, Y, X. And we have this extra button for turning on self-driving or obstacle avoidance. Actually, there's no self-driving here. And turning it off. Here we have a joystick. Like this one. Like this one. Now, I don't have 2. Because I'm lazy to add another one. I could add another joystick because I have like an old thing where I can get the joystick from. Not an Xbox controller, of course. Yeah. But let's talk about this button. So basically, this controller, actually, I was thinking of driving it in one way. So we could use these buttons for forward, left, right, and reverse. Also, if you look at this potentiometer, sadly, I broke it because of heat. I was soldering it. Yeah, I put the soldering iron too long on it, and it just damaged it. So it's unusable. I was going to use this to actually control the speed, increase the speed, or reduce it to 0. But it's now out, and it's a sad thing. Also, you might know that the joystick has a button in it. As you can see, meaning we have another point of input. I'm not sure what this button will do for me. But let's talk about the main point of this, which is controlling the truck. Here are the controls. Using this paper, I'm going to draw some controls. Now, even though my phone was green. Now, as you can see, this is our thingy. Now let's move over to a sketch that will help us understand the controls. As you can tell, this is like a copy of this, but on paper. But let's get the paper closer. So yes, let's start explaining. Excuse me. Now, if you could see, these are different colors. But first, let's start off with the basics, okay? This is a built-in cooling fan on and off. So in here, on and off. Now, here's the built-in cooling fan. I'm going to open up this thing and show you inside, so for later. Second button is here. This turns on the obstacle avoidance. Right? Which is here. You can turn it on and off. Now, next up, we have all these lights. I was lazy to draw them, so whatever. Please ignore the artistic skills. Now, I have this switch here for switching modes, as you can tell here, and the joystick is this. Now, let's on this useless potentiometer. Anyways, let's talk about the most important part of a controller, controlling the truck. Okay, so first we have the joystick. We're gonna turn on a mode. Let's put in the off mode. The off mode will allow you to use the joystick to steer left and right. Okay? And you'll be able to use the Y and A button. Oh, I forgot to draw. For forward and reverse. So forward, reverse, left, right. Now having the joystick is because the joystick can have precise input, so it allows you to control the specific angle of the truck's wheels using the joystick, because it has precise measurements here, as you can see. Not just a push button, they'll just send it to 100% right away, which is way better. Well, not right away, by the way, yeah, but you know it, you understand me. So yes, joystick is for precise controls. This is why I'm fighting over it. Now, let's put it on the on mode in imaginary. The on mode will allow us to use the joystick to control the direction, like forward and reverse, but we don't have precise control over the speed in that direction. So if we want 100% speed, we're gonna put the joystick 100%. Well, 50%, we're gonna put halfway and stuff like that. So this will allow us to have precise control over the speed and direction as well, which is good. And we're gonna use these buttons to steer left, right. So left and right. The problem is a little problem. No, it's not a problem in reality, but you know, as the servo motor will be just sent, when you click this button, it will send it to 100%. So you don't have to have precise control over the steering, which is not preferred usually. I guess it is a luxury to have a joystick. Now, a great idea is to add another joystick and still have the buttons for, like, I don't know, something else I come up with. So having another joystick will allow us to control direction and speed in precise measurements depending on how much I want it. I can have control precisely of the direction and speed at the same time of the steering and the forward and reverse movement, which would be great. So adding a second joystick should be my top priority here. But in the current layout here, that's how it works. Now, I forgot to show you something. It's called the inside of this beauty. Now, as you can see, it fits over here. Hey, actually kind of drew down point. I used the ruler. Anyway, let's open this up. Now, I don't prefer to open this up because the inside of the wires, right, they can get disconnected from the Arduino, and yes, this is where the Arduino went. So let's just open it like this. Using one hand is hard. Now, as you can see, it's a button for the cooling fan, and it's a cooling fan, and it's a button for the self-driving. Oh, all the buttons are up here on the lid. You can see the pins? You can separate this thing from the Arduino by removing these pins. I forgot to tell you I also have a vibrating motor here, just so it can provide feedback. Maybe it crashes into a wall and you're so close to a wall that it just vibrates to warn you, you know? That's a good feature. I'm gonna have to put these pins back in the Arduino, but here's my Arduino. Yes. This is where it went, and as you can see, all the pins. It might look a little messy, as you can see, but here it is, the inside. Now, I need to rewire it by closing it. I can't do this with one hand, so let's see for now. Putting the sink off the shelf, we're going to a truck. Now for our truck. We're back to our elastic band project. It's time, it's time to test it on the road. Before gluing these on, I don't want to glue these on, because that will make them like almost permanently on, and when I remove them afterwards, there'll be a little layer of glue left on the wheel that it'll be difficult to remove, or even impossible, making the wheel kind of bump every time it drives a little bit slightly, which won't be that big of a problem, but I do not want to risk it. Now let's test without gluing them in place. Of course, this is going to be a disaster, because these rubber bands just fly off sometimes. Now let me flip that thing over. Oh, if you love an introduction on how it drives, let me show you. Now if you look inside here, well, you can go inside there. Hold on. Okay, so basically, this is a servo motor, as you can see the arm there. It controls the wheel. It has 11 kilograms of torque, but I'm giving it 5 volts, so it has a little bit less. I forgot, I don't have the spec sheet on me right now. We have this is the driver for the wheels. It can take up to 43 amps. It's rated 43 amps. But someone tested it, it was like 30 amps, but that's still okay. That's because my motor here is 120 watts, meaning it takes 24 volts and 5 amperes. And I'm not gonna bore you with the rest of the stuff. Now it's on its wheels. Beauty. Now look at the back. We can see a temperature sensor. Blue thing here. The buzzer is just back next to it. And the lights. Oh my god, one light got removed by someone. Hold on, I can put that back. I have it on. Don't ignore all these wires. They're just a mess of wiring. Wait, this thing uses a belt to drive the gear. Now this is if you don't know this, as you can see, the driving motor has a small gear, and the driven motor driven wheel has a big gear. That creates in that we have basically what do we call it? It's called gear reduction or something. I forgot. So basically, this is where I convert speed into more torque. So I lose speed from this motor. This wheel will have less speed, but higher torque. And because it's a dump truck, it needs the torque. And if you tell me, oh, this is overly useless torque, no. You know, I once carried how do I say this? About 6 kilograms of glass bottles full of water on the back of the truck, and it could do it, so I guess we're good. This is my beautiful display. This thing here, you put a screwdriver and controls the brightness. But it kind of works on one certain brightness, so what happened here? Okay, so this is supposed to be on over there. Now this is so it can protect your eyes from this super bright LED. I put a little too much voltage. I gave it 3.3 volts. I think it's rated 2.7 or something. I'm gonna have to find that little piece. Man, that's saddening. It doesn't look as good anymore because I like this more. Okay. Oh yeah, by the way, this is my ultrasonic sensor. This measures distance using the speed of sound. This is a motor to make it turn left and right, so it can have a higher field of vision, so it can look left and see the obstacles, right to see the obstacles, or anywhere it wants. I am going to replace it with a servo motor I have right now on me, but I'm lazy to do the wiring, and I have exams soon, so that was too much information. So let's put it down. Also, I cannot, I'm scared of moving this wheel and damaging my servo motor, because that happened before. I damaged the servo motor by forcefully moving it left and right, I think. So let's put it down. This is hard. Okay, I'm scared. Hold on. Okay, so I'm now flexing the ability that my truck has to get off of steep angles. As you can tell, this is a steep angle. Let's see its face. No. Let's just let it go down. Now watch the back. If this thing scrapes, that means I fail. Did it touch? Maybe not you guys just. Hold on, I can't see it as well as you guys. It's all. That was a jump scare. Hope you didn't see my face there. And we're off. Now, actually, the biggest reason for this rubber band is to reduce noise. And the grip part is really kind of a side thing. It is a good thing to have, but I would like to also reduce noise. So as we can tell, it's moving. I had no problem with this driving on this on any mat or any padded surface on a floor. But the biggest problem is it driving on these very slippery tiles. I forgot what they're called. I can notice it's quieter than before, and if you hear that sound of tick 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 tick, this is the sound of the wheels kind of hitting against some sort of wire. That's okay, since I'm gonna remove that wire in the end, so don't worry. It has better turning, in my opinion. I don't want any understeer or oversteer. Let's open that door and have it tested in the real world. Oh, it turns. It came off. For the test to work, it has to be on. Oh, here it is. It's less loud, but not as much. I think these look good on it. I'm not sure about the rubber wheel's decision. It does reduce noise a little, but it's still present. I think adding more rubber will reduce the noise further. But we leave it for maybe like next month. So yeah. See you next month, and hopefully I will order an Arduino Mega, which is way bigger than Arduino. Not way, but like, I don't know, it's like 3 times bigger or 2. Yep. You might be wondering, hold on a second. I have not seen any receivers or transmitters anywhere in this whole build. Now that is correct. I actually have a transceiver, a receiver and a transmitter in one. It basically can do the both. And we need this to connect through kind of a radio signal to be able to communicate between the car and the thing, because how are they going to talk to each other without that device? So let me show you basically the antenna, or whatever you want to call it. Also, I forgot to tell you, this used to be a shell of an old router. As you can see, here's a beautiful circuit board. Now, it used to be like in here like that, inside the box. I cut off the place where there were LEDs placed out because I want them. And basically, I'm going to rewire them into the Arduino so they can be used. This router is useless, and I think it might be broken. It is broken. There was like a lot of burn marks inside. Even though I can't see a burned component, it is beautiful though. Aside, I am using, here's the antenna of the transceiver. As you can see, here it is. Now this transceiver, you need 2 of it. 1 to transmit and 1 to receive. This is not Bluetooth, and it will not connect to your phone. Meaning you cannot buy this and say, oh, I'm gonna use this for my phone. Oh, wait a minute. Is this a solder bridge? Guys, my camera. No, it isn't. As you can see, HC12, beautiful. And here's the antenna hole, replaced. Here are the beautiful components. And I've seen 2 versions. One with the components looking a little different. But I bought this one. I will have to buy another one next month. I bought it thinking it'll connect to my phone's Bluetooth, but nope. It works on like kind of a Bluetooth, a radio signal, which my tablet and phone doesn't have. So yeah, here's my toolbox. If you'd like to look at it, let's turn it off and goodbye. Actually, no, let me show you some schematics now. Of the build, some wiring, diagrams, and some stuff. So let's go. Let's start simulation. Plugging it in, the beginning of a code, you will see the servo will be set to 90 degrees perfectly so the wheels are centered. Ignore the lights exploding, over voltage like I said before. But mine are not exploding and I'm lazy, so yeah. These 2 lights are here to test the PWM. Oh, sorry. Don't mind them, like these 2. Like over here and here. So, yep. Hold on. This is a 27 megahertz receiver from an old RC car. You can ignore this. Now, as you can see here, this is a 12 volts motor, a 12 volt battery connected to the motor directly. In reality, it's connected to that chip I showed you, which I can show you as a chip right now. Now, here's the motor driver. Is supposed to be in between this, as you can see. Now this is here to show you that I put a diode to eliminate the threat of me reversing the wires and damaging this driver here. That's why I put a diode. The diode only allows electricity to go in one direction, which means if I flip my battery, it will not actually, it will cut off the electricity anyway. Here's the name of it, BTS 7960H Bridge. And here's how it looks like. Yep, it's still simulating. Anyways, that's it. As you can see, I gave 12 volts here and I gave 5 volts here. I'll actually use my power bank to power this thingy and servo motor. So servo motor gets 5 volts, even though it's rated 6 volts. I can also show you my servo motor. One sec. Now here, oh sorry, is a spec sheet. If we look, we can see some information. I got it off of Google, so it's on mine, of course. Here are specifications. Now these are important. The weight is 55 grams. The dimensions, as you can tell, the stall torque is 8.5 kilograms per centimeters at 4.8 volts. Now I give it 4.5 volts. So let's say the stall torque of it now is like 9 kilograms. It can deliver 10 kilograms per centimeter at 6 volts. Not 11, that's weird. Whatever. I did buy the 995, not 996, so yeah. The operating voltage is 4.7 to 7.2. Oh, I saw it was like max 6 volts. Okay, so I guess it can go 11 kilograms per centimeter, 11 volts. Maybe, but they didn't tell us here. Temperature range is from 0 to 55 degrees. Here, yeah,